Introduction. The world of technology continues to evolve at an astonishing pace, and sometimes connecting legacy hardware with modern components can lead to exciting possibilities. In this article, we'll explore the concept of creating a hardware interface between a W65C02S microprocessor unit, MPU, and a cutting-edge NVIDIA RTX graphics card using shift registers and a PCI Express, PCIe slot. We'll delve into the required supporting hardware, firmware considerations, and the potential benefits of such an interface. The W65C02S MPU and NVIDIA RTX graphics card. The W65C02S MPU is an 8-bit microprocessor known for its use in various applications, including retro computing and embedded systems. On the other hand, NVIDIA's RTX graphics cards are renowned for their high-performance graphics rendering capabilities, making them a favorite among gamers, content creators, and professionals. Creating the interface shift registers. To establish communication between the W65C02S MPU and the NVIDIA RTX graphics card, we employ shift registers. Shift registers are serial-in, parallel-out devices that can convert data between serial and parallel formats. These components play a pivotal role in adapting the data communication requirements of the two disparate devices. PCIe slot. The PCIe slot acts as the physical connector for our interface. It provides a high-speed data pathway between the MPU and the graphics card. PCIe is a widely used interface in modern computers for connecting various components, including graphics cards, storage devices, and networking cards. Supporting hardware-level shifting circuitry. Given the voltage differences between the W65C02S MPU and modern GPUs, level shifting circuitry is necessary to ensure proper signal compatibility. Clock synchronization. Both the MPU and the graphics card operate on different clock frequencies. Implementing clock synchronization hardware ensures that data is transferred accurately and without data loss. Data formatting logic. As the MPU and graphics card might use different data formats, a logic circuit is needed to convert data between the two formats. Firmware considerations device. Drivers. Writing device drivers for both the W65C02S MPU and the NVIDIA RTX graphics card is essential. These drivers act as intermediaries between the hardware interface and the operating system, enabling seamless communication and data exchange. Data protocol. Establishing a standardized data protocol that the MPU and the graphics card can understand is crucial. This protocol defines how data is structured, transmitted, and interpreted on both ends. Error handling. Robust error handling mechanisms should be implemented in the firmware to manage data integrity and prevent crashes or malfunctions. Benefits and potential applications. Retro-modern computing. By connecting a legacy W65C02S MPU with a modern graphics card, enthusiasts can explore the possibilities of combining classic computing techniques with modern graphical capabilities. Educational purposes. This hardware interface project could serve as an educational tool to demonstrate the intricacies of hardware communication, data protocols, and device driver development. Custom computing solutions. This interface could open doors to customized computing solutions, where legacy hardware can be utilized alongside modern components for specific applications. Conclusion. Creating a hardware interface between a W65C02S MPU and an NVIDIA RTX graphics card through shift registers and a PCIe slot is a fascinating endeavor that blends the past and the present of computing technology. The successful implementation of such an interface requires careful consideration of supporting hardware, firmware development, and data communication protocols. While this project presents its challenges, the potential benefits and applications make it a compelling exploration into the world of hardware interfacing.